How does the Bloch sphere explain quantum qubits? Have you ever wondered how quantum bits, or qubits, operate in the world of quantum computing? The Bloch sphere is a fantastic tool that helps us visualize and understand these fascinating entities. Let's break down how this geometric representation works and what it tells us about qubits. First, let's clarify what a classical bit is. A classical bit can only be in one of two states, 0 or 1. In contrast, a qubit can exist in a superposition, meaning it can be in both states at the same time. The Bloch sphere captures this concept beautifully. It maps every possible pure state of a qubit to a point on the surface of a sphere. At the top of the sphere, you have the state representing 0, and at the bottom, you have the state representing 1. Any point on the surface of the sphere represents a unique combination of these two states. This is where the angles come into play. The angle from the North Pole down toward the equator is known as theta, and the angle around the vertical axis is called phi. Together, these angles define the exact state of the qubit. Now, let's talk about superposition. The position of a point on the sphere shows how much the qubit is in state 0 versus state 1. Points along the equator representing equal superpositions of both states. This visualization helps us grasp the richer information space that qubits offer compared to classical bits. Next, we have quantum gates, which are operations that change the state of qubits. These operations correspond to rotations of the Bloch vector around the sphere. For example, the Pauli X gate flips the qubit state by rotating it 180 degrees around the x-axis, effectively swapping the states of 0 and 1. Another important aspect is phase. The angle phi encodes the relative phase between the states of 0 and 1. This phase is crucial for interference patterns in quantum algorithms, which do not have a classical equivalent. Lastly, we should mention mixed states. While pure states lie on the surface of the Bloch sphere, mixed states, which representing statistical mixtures of qubit states, are found inside the sphere. The center of the sphere represents a completely random state. In summary, the Bloch sphere provides a clear and intuitive way to representing and manipulate qubits. By translating abstract quantum states into geometric points and rotations, it becomes an essential concept for anyone interested in quantum information theory and quantum computing technology. Understanding the Bloch sphere is key to grasping how qubits function and how they can be used in advanced computing.